Hi everyone, welcome back to another anatomy episode. In today's video, we are going to go over long bones and osteons. Osteons are the cells that compose up bones. So please like and subscribe for more content. And now let's get into the first topic of discussion. So the first thing we're going to go over is bone shapes. You have a couple different bone shapes, the first of which is your short bones. Short bones are going to be examples such as carpals or your tarsals, so your wrist and ankle bones. Then the next one is your long bones. These are pretty much your appendages, meaning your arms and legs. So some bones that make up these ligaments is like your humerus, femur, tibia, those would all be considered long bones. Another example of them is the phalanges, so your fingers, those are also long bones. Even though they are very small, they are still classified as long. Then you have your pneumatized bone. This is primarily your septum, which is in your nose. So your nasal conchae, that would be an example of a pneumatized bone. Irregular is any bone that doesn't fit into the other categories. So a vertebrae, it's very oddly shaped, and depending on which region of the back you are in, cervical, thoracic, or lumbar, the vertebrae are going to look a little bit different. So they are classified as irregular. Then you have your sesamoid bones. One of the primary examples, and very few places that you can see this type of bone, is in your patella, which is your kneecap within your body. Flat bones is the next one. This one is actually quite popular within your anatomical structure. So your scapula, aka your shoulder blades, those are flat bones. Your ribs, are flat bones, and then the different bones that compose up your skull, so frontal, parietal, occipital, and temporal bones, those are all flat. And then finally, your sternum. Then the very last one is your sutural or wormian bones. In your skull, you are going to have different sutures, aka kind of like these cracks in between your different bones within your skull. So, like in between your frontal and your parietal bones, you might have a suture over there. And that bone that is kind of like in that region, that would be considered a sutural or wormian bone. Another example is when you are born with fontanelles, which are these soft patches within your skull. And as you develop and get older, then that fontanelle is going, or the fontanelles, plural, is going to turn into bone within your skull. So that's why some babies that have misshaped heads might have kind of like a cast on their head so that when they develop, their skull can be round and not misshapen. Here is a nice picture from my lab manual about all of the different shapes of bones. So over here at the top left corner, you can see some examples of short bones, while in the bottom right corner, you see an example of a long bone. So you can see these ones are very stout. This one's a little bit more lengthy. Then up here, you have your pneumatized bones. So these are like the nasal conchae here on the sides. This is your septum over here. This is pneumatized. Irregular, this is a vertebrae. A flat bone, this is your scapula, aka shoulder blades. Patella is a sesamoid bone. And then this is what I was discussing over here, where this patch used to be a fontanelle and then it developed into a bone as the person becomes an adult. And so this is a sutural or wormian bone. Next, we are going to transition into this diagram over here, which shows this picture of a long bone. So I'm going to start off by drawing the different sections. So for a long bone, you have three distinct sections. This one over here, and you can see in this diagram over here. So this top part of the bone. This is going to be your proximal epiphysis. The proximal epiphysis. Then you have this longer shaft over here. This is like the length of the bone. This whole region is going to be your diaphysis. Increase the size of that diaphysis. And then finally, this last portion at the very bottom on the other side of the long bone. This is your distal epiphysis. So this is where your directional terms really come into play with proximal versus distal. Proximal is on the upper side, diaphysis, and then distal is on the lower, kind of more inferior side. So within your epiphyses, you can see that you have spongy bone. If you zoom in, you'll see that this kind of looks very cushiony, everything like that. That was a bad circle. I'm going to redo that. This is like a better portion to circle over here. But it looks very cushiony. Same thing on the other side. Looks very spongy. There's a lot of tiny little holes within the bone. So that is your spongy bone. Now, spongy bone is filled with red bone marrow. So this would be a region where you find red bone marrow. And red bone marrow is, shockingly, made up of red blood cells. So equals red blood cells. And spongy bone itself is basically going to have lots of columns that are called trabeculae. And the trabeculae is then surrounded by endosteum. Endosteum. So basically, spongy bone on the epiphyses, so proximal and distal epiphyses. Within the spongy bone, you have red bone marrow. Red bone marrow is made up of red blood cells, aka just your blood. And then spongy bone in itself has columns that are called trabeculae, and surrounding spongy bone is endosteum. Next, if we look at the diaphysis has compact bone. So this is compact bone. Compact bone is surrounded by not only endosteum, such as in spongy bone, but also periosteum. So surrounded by endosteum plus periosteum. Another thing about this diaphysis portion is that in the center, you are going to have yellow bone marrow. So that is where you would find yellow bone marrow. That's the only place within this long bone. So it goes red bone marrow, yellow bone marrow, and then red again at the distal epiphyses. All right, next we are going to go over the epiphyseal line. The epiphyseal line is basically going to just be your growth plate. I'm going to kind of just label it over here would be a good example because this over here would be like your hip. And if you're thinking like you are growing and extending from your hips. So again, epiphyseal line. So if you have a lot of like hip pain when you are going through puberty or growing, that can be because your bone is literally like building upon itself in order to lengthen out. So it's kind of a very painful process, and that's where a lot of people will get kind of those um, conditions or injuries that are directly tied to growing. One example is Osgood-Schlatter's, which is in your knees, and it can really be painful. I had it once, and it was not something that I would want to experience again. Now, over here on the ends of the epiphyses, so on the proximal and distal epiphyses area, you are going to have articular cartilage. Articular cartilage is basically going to cushion your bones, and it's going to help reduce the friction between bones. So if they ever talk about kind of like arthritis or anything like that, that is actually because you are then bone on bone and you are missing that articular cartilage in between your joints. And it can be really, really painful because your bones will end up grinding against one another, since there is nothing to kind of cushion them and keep them moving along smoothly. So again, this is your long bone anatomy. It's pretty simple and not really complicated when you kind of just like hone in on the different little aspects. And there's definitely a lot of patterns within the bone, which can help you remember some of the things. All right, now moving on, we are going to go into the anatomy of a singular osteon. And again, an osteon is a cell that makes up the bone. So this would be a diagram of one osteon. Within your osteon, you have the first part, which is your central canal. The central canal is basically going to be this middle area over here. So that is a central canal. Then you are going to have all of the different layers, which are lamellae. So you can see that you have like this layer over here, another layer over here, another one, kind of like an onion, if you ever chop up onions, tons of layers. So that is the lamellae. Within, or I would say more like in between those layers, you have these little holes, one over here, there's there. They kind of look a little bit like eyes. So these holes are your lacunae. Lacunae, all right? So that is what those are. Then you have your canaliculi. You can see these over here. They're labeled in red. All of these kind of vein looking slash tunnel looking like red springs that are coming from the lacunae. These are all canaliculi. So the red canaliculi also means little canals or little tunnels. So it is really easy to kind of remember the name if you know the root and what it stands for. All right. Now we are gonna go to the next picture. This is still an osteon. It's just that it is a side view of an osteon so that you can kind of see like deep down because this is a picture taken from the top of it. Now we're going to the side and we're looking deep down. If you were to cut an osteon in half, this is what it would look like. And you have all of these different canals. So the ones that are running vertically, these are your central canals. So this one over here, there's another over here. Those are your central canals. And also, if you look at the top view that I was just labeling, imagine that this canal here in the center, it just goes straight down. So it's up here at the surface over here, and then it goes straight down. So that is the same central canal. Next, you are going to have your Volkmann's canals. The Volkmann's canals are the ones that are running horizontally. So that one over there. This is also a Volkmann's canal. This is one over here, and then on the very end over here, that is a Volkmann's canal. Within these canals, both the central and the Volkmann's, you are going to have blood vessels, lymphatic vessels, and nerves that are running through these canals. So, once again, within canals, you have blood vessels, lymphatic vessels, and nerves running through them. Right over there. All right. Now, the very last thing that I want to go over is the difference between interstitial growth. Ooh, that was kind of a rough line. Let me redo that. There we go. That's a tiny bit better. Not very much, but a little straighter. So again, the difference between interstitial versus appositional growth. So these are two different types of bone growth that can occur within your body. Appositional is the other one. Now, what happens in oops, let me spell that right. What happens in interstitial growth is that it is basically going to be making bones longer. So makes bones longer. And the way it does this, oops, there we go. The way it does this is you have cartilage cells called chondrocytes. And these chondrocytes are going to be stacking up on top of each other in order to make the epiphysis and the diaphysis longer. longer. And so basically, that is how you are growing within length. Because as we can see over here, these chondrocytes are going to kind of just like be stacking up on top of each other throughout the whole length of the bone, and then over time it is just going to increase the height. Now, the difference is appositional growth. Appositional growth is going to be widening the bones or growing wider. And with appositional growth, it's a little bit different because you have osteoblasts that are going to be like growing on the outside, stacking up on each other again to thicken the bones, but on the inside, osteoclasts are breaking down bones on the inside. And so it's kind of like a little bit of a hollow type of thing. So you are breaking down bone in order to build up bone. So that is how it grows wider, is because you are breaking down bone within the center, and then you are building upon it on the outside. So over here within the spongy bone, you'll see that it's very porous on the inside, but it is wider than the diaphysis region, which has compact bone, because compact bone is going to have a lot more substance within the inside. So like this border over here is compact bone. It's going to be a lot more compact, but it's not as wide, while over here it's more porous, but it is wider. So that is pretty much the main difference. And now that's the end of this video. If you have any questions, comments, concerns, leave them in the comments and I will get back to you guys. Again, please like and subscribe so I can keep making videos and have the resources for everything. I will see you guys next time, and please keep studying. You guys got this, and you're doing really great. I'll see you. Bye.